Bismillahirrahmanirrahim. Assalamualaikum and very good afternoon to all. Okay, for today's TRIZ class on structured problem solving, we will be discussing about the structured problem solving and understand how step-by-step process on what are TRIZ tools to solve structured problem solving, and know the advantages of using TRIZ to complement the structured problem solving. So, as you all may know, the structured problem solving is basically one of a way to look at the root of the problem. For example, if you remember the Ishikawa, if you heard of Ishikawa diagram or the fishbone diagram, this is similar to that, which is also similar to the TRIZ structured problem solving. Let's look at it step by step on what are the structured problem solving process. There are 7 steps in solving the structured problem solving. The first is to define the problem statement. Knowing the problem statement makes the process very much easier to solve. The next is to understand the current situation, meaning solving the current problem and go back to the general problem can help us define what the solution to the general problem is and solve the current situation. In order to do that, the third step is to identify the causes. To identify the causes, we need to look at the most basic causes of all. After that, we can develop the fourth step, which is the solution. And finally, on the fifth step is to implement the solution through several process known as the trimming process in this current lecture today. And the sixth one is to do a standardized solution where we can solve the current situation using general problem solution and solving it using a standardized solution. Finally, we can go to the next step, whether if the solution is solved or not. If not, then we go back to the first process, which is to define the problem statement. Now, let's look at one by one what are the definition of the step. Now, definition of the problem is exclusively to identify the problem and the importance of the working on it. For example, when we look at, say, the issue of the internet in the university, so we look at what are the main cause of the issue of the internet. Now, we may look at several factors that affected the internet. The first is the factors that affected the internet is the internet may be out. The internet may be very slow. The internet is working sometimes and not working sometimes. So, and these are the 3 factors that we look at. So if the internet is out, we need to establish the process and so on. So the output is to establish a team to determine whether this process happens, and we will need to provide develop a problem statement. So the general process of having no internet in the university, for example, is due to these 3 factors. So explain what's the step-by-step is of these 3 factors. What are the nature of the problem? So the internet usually is out due to what nature of the problem? The internet is slow due to the what nature of the problem? And the internet is sometimes fast and sometimes slow is due to what nature of the problem? So we need to find the symptoms and resources to solve this problem. The second is the current situation, which is the step. Okay, the purpose of this is to clarify the problem area as the situation exists. Now, this is similar to the objective scope. If your scope is the university, the internet, then focus on the university of a certain university, not focusing on the entire, say, Pekan, for example. Focus solely on the internet and focus on what is internet requirement is. So internet requires electricity, for example. So focus on the main source. Okay, the internet requires connection, wireless connection, for example. The internet requires cable, for example. The internet requires hardware and software. So focus on these 3 things. Create this problem description to understand what are your current situation are. And the third is the identifying the causes. For example, What are the purpose of identifying the causes? The main point is to identify and verify the root cause of the problem. That is the main point. If we solve only the symptoms, then we will not be able to understand what the cause of the root of the cause is. Thus, we may not be able to solve it directly, which is the most important part in our daily life. So the output is to isolate, cut what we don't want, and verify the root cause of the problem. Next is to develop the solution, how to solve the solution. From there, we can select which are the more important and develop a test and test the solution to eliminate the root cause. This is the purpose of develop the solution. The output is to fix the problem at the root cause level and generate no additional problem. And finally, the fifth one, before we go to the step 6 and 7, we implement the solution by implementing the corrective way how to solve the solution. So the output is to implement a plan, a risk and barrier to identify the solution and validate that the corrective action needs to be working. And the sixth step is to standardize the solution so that this solution will be able to be used in other parts of the system. For example, not only when I say internet, we can also be used as, for example, water, for example, or air conditioning, for example, or computers, for example. So to ensure that the improvements are sustained over time and the output is the solutions can be used in similar equipment and similar processes. And last but not least is the purpose of the next step is to evaluate whether our solution has accomplished or not. And if our completion has accomplished, we can document the process, update the document, and publish and report findings so that other people will understand what we are dealing with. Now, the structured problem-solving process and TRIZ is almost similar. Now, defining SPS, structured problem-solving, which is step 1 to step 7, when we compare it to TRIZ, we can see several similarity between TRIZ and SPS. For example, when we say functional analysis of product or process or ideality, that means it is a definition of the problem and the current situation. The current situation can also be expressed in cause and effect chain analysis, problem commonality analysis, and scientific effect. So these five important aspects in TRIZ can be used to define the SPS number 1 and number 2 steps. In steps number 3, 4, 5, and so on, can be used to use like cause effect analysis chain, engineering contradiction, physical contradiction, substance, field, 76 inventive solution, 14 inventive principle, trends of engineering evolution, and ARIZ, which is algorithm of inventive problem solving. However, this important aspect in TRIZ are not fully covered, all of it. For this class, we will cover the cause effect chain analysis, engineering contradiction and physical contradiction, and as well as the 40 inventive principle. Apart from that, you need to study more to understand what TRIZ is all about. So the main point in this discussion is that the TRIZ complements the structured problem solving. It helps to improve the structured problem solving, and TRIZ is also known as the power tool to add to in the innovator toolbox. So we'll be applying SPS inside TRIZ to know if it can be helped. Let's look at an example. Before we go to the example, let's look at the plan, do, act cycle and the real world. As you all know, human activities, they focus mainly on these 4 aspects: act, plan, do, check, and then act. Example, we mostly focus on plan. And then once we have the plan, we do the process and we check whether the process is done. And finally, we act on the information, but we go back to the plan. Okay, that's the ideal factor. But in actuality, plan, not so much. We mostly focus on solving, acting first, which is firefighting, and we do more. So meaning we lost a lot of money in comparison to the main act. And lastly, we don't check because we know it solves the problem, so we don't need to recheck back. That's the actuality. So humans usually have much happiest situation when they are able to solve it rather than they have the plan to it. So this scenario is actually what we are dealing with. Now, TRIZ encourage us to stay in this defined mode as long as possible to both what we understand and what we don't understand. So let's look at the process. For example, in TRIZ tools, we will focus on the cause and effect analysis. Why this cause and effect analysis is important? Okay, what type of cause and effect analysis that we're going to use, how to use this cause and effect analysis, and some exercise that we will be looking at in the case study. Okay, the cause and effect analysis is similar to the SPS process, structured problem solving. The cause and effect analysis generates hypotheses about the problem. So we first focus on how to solve the hypothesis, and finally we understand what effects that can cause from the hypothesis. The cause and effect analysis diagram can be a process of structure, helping us to understand the hypothesis that we understand and whether this hypothesis is basically true or not, and is it happening or not. From there, we can determine the solution. Okay, it helps to focus the attention and the process, as well as whether the problem will be occurring or not, and allow us to constructively, okay, use to narrow down the actual causes. Although it may not be able to replicate this from testing, because testing requires time and consume a lot of money. So we cannot compare this to testing, but we can do that by applying this cause and effect analysis to find the root cause. These steps is similar to the 7 steps that we obtained from the SPS. Okay, step number 1, we agree that the problem and write it in the effect box. Step 2, we use brainstorming analysis that we did also in the previous lecture about likely the cause, and then sort them into a major categories of branches depending on the method chosen. Step 3, to continue to brainstorm and generate a list of causes and fill them in the appropriate categories and branches. Step 4 is ask. This is the problem where we do checking. Ask why and what else. Okay, for the potential of root cause that are going to benefit us later on. Step 5 is to use team-based collection judgment, discuss this with your teammate, and eliminate the unlikely cause. And step 6 is to use the reduced list of likely cause to develop effective hypotheses to prove the theory. And we need to validate this hypothesis to confirm whether this root cause is the real root cause or not just the symptoms of the cause. An example, for example, kita ambil contoh, there is no light when switch is turned on. Okay, when we go to a room, we try to turn on the switch, we look at the lights, the lights is not turned on. So we believe there are a couple of things that may be your focus. Probably the power is out, so no electricity occur. And we also can look at the light bulb is not working. That will be the main problem. The switch is broken. The other could be the body of the light bulb is not working. So we will take a look at some of the consequences of it. Why this happens? So if we look at the power out, we may say that the power in other classes is still on. So that will eliminate us from the issue. And we look at the other switches, we turn on to the right switches, possibly an air conditioning switches, and the switch on the aircon is turned on. So we may eliminate these testing possibilities with other cause. There may be other issue regarding about the other factors. For example, the light bulb. So we may maintain this. The light bulb no longer works. It may focus either based on the light bulb issue or the body of the light bulb. So these two may be causing the main situation. Other apart from that, we may consider other things. But kalau kita ambil contoh, we don't pay our bill, that is not the real cause. Okay, ataupun the socket, okay, the wire is cut off. That is that is something that we cannot oversee. Jadi kita tak boleh nak assume that to be there. So we are only able to assume something to be there only by the look of our eyes. Now, for example, we look at others. Let's assume that the body is correctly, properly working. So we may believe that the light bulb is not working. So we go to the next step. Why? This may be due to the filament is broken. So we open the socket. We look at the filament is broken. We can also change the other, which means that the body of the light bulb can be placed also here. The socket is cracked, for example. Or others, for example. What else can be described here? So if both of these are not cracked, so we may be looking at the filament is broken. So why if the filament is broken? It may be already wear out because of the extended life of its self, or it may be due to the current spike. Due to the current spike, sometimes through lightning, through many other aspects, it can cause filament to wear out. So we can decide these two may be the main factors. Now we go to the final stage, to finally how to solve the issue. So these are the root cause. So we know this is the main cause, and how to solve from this is we go focus on due to the normal wear. That will make, meaning do we be able to solve this by just replacing it with a new light bulb. Or manufacturing issue, we may contact the manufacturer to say that this issue and can help the manufacturer improve the light bulb. Or if there is a current spike, we may need to go to the protection circuit, determine whether the wire is has a problem, and we may need to contact other technician to fix the issue. Or due to the power spike from the grid, then we may need to contact the TNB to explain the issue. So these are the solutions that can be obtained from the root cause. So this is known as the cause and effect chain analysis. Okay, so this cause and effect chain analysis has several, you see there are many crosses here. So these crosses can be explained as the TRIZ tool trimming process. So the TRIZ tool trimming process, if you look at trimming, you know that trimming is actually a method of eliminating a certain component from engineering system to reduce or eliminate the disadvantages of those trimming component. Trimming is used to increase the efficiency and reduce the cost of engineering system. For example, there are 3 trimming rules that needs to be looked at. The first rule is the function is not needed anymore because the object of the function no longer exists. Okay, the second rule is the object being worked by the function performs the function itself. Okay, and the C, meaning if you look at this example, the trolley are not in use anymore because we have applied the roller under the baggage. So the function itself, the trolley and the bag is not useful anymore because we have this already as our it's already applied 2 function in one. For example, this one, usually we do have a speaker, and we apply this on the speaker to detect the sound. Now we don't have to do that. We'll just use this to determine, and we just use a disc, and now we're not even using this anymore. So this step of process is not needed anymore. This one, this process is this is no longer needed. This is the function is not can be improved, and this one it can be transferred to another component. For example, the table does not need a frame or a stool or a foot. It can share through the 2 chairs, or the table does not need a stool. It can share with the wall. the gazebo, or it doesn't need a shade because the trees helps to cover the shade of the lights, for example. So these trimming tools must be considered based on this equation. The trimming factor which is function squared over problem plus cost. If you remember the ideality equation, see, this is similar to the ideality equation, but the ideality equation comes from the trimming factor comes from the ideality equation. So if the function has high functionality, lower problems, and lower cost, meaning that it is the factor that we all want in our daily life. If the function has very low functionality, high cost and problem, that means the issue is can be regarded, and we can use our rule A to remove this. Okay, so in your assignment 3, I have given a certain example of how a problem occurs. So you can apply this three-main factor, okay, rules, as well as the cost and effect chain analysis to do in your example in assignment 3, where I give you some example, and you can use this cost and effect analysis to understand and how to use the branching process as well as the trimming process. So that is all for today's class. I will see you again this Friday online to complete our assignment. So complete our TRIZ 4 and TRIZ 5. And another important information that I would like to share is that next week, actually, we want to cover the test 2 on 7th of, if I'm not mistaken, is on the 7th of January, but I have a issue that we will not be able to do the test on the 7th of January, so we will be extending it to the 9th of January at 5 to 7 p.m. But I will let you know instantly next week, this Friday, about the test. So that is all from me. Thank you very much. Hope to see you this Friday. Assalamualaikum and very good afternoon.